Hey folks, we only had time to look at one problem in 6.1, but I want to go ahead and talk about it. We're talking now about functions, and specifically now properties of functions like one-to-one, onto, or neither. It's possible that they would be neither one. So let's take a look at problem 3, which has 3 functions there and asks us to determine whether they're one-to-one, onto, or neither. The first one, the A part, is a function from 0, square bracket 0 to infinity, into open 0 to 1, close bracket, so which means bigger than 0 but less than or equal to 1. Okay, defined by 1 over x plus 1 quantity. Well, if you look at the graph, and I'm just going to kind of quickly draw the graph here, you know, when x is 0, this is 1. And as x gets bigger, this thing asymptotically gets close to the x-axis, right? So if you think about this in terms of one-to-one and a horizontal line test, right, it would pass a horizontal line test. So it is going to be one-to-one. And also, it's going to cover everything between bigger than 0 and less than or equal to 1. Okay? But let's talk about, now's a good chance to talk about how you would prove such a thing. Okay, so let's show, if I were going to prove this, how I would prove it. Okay? So, let's suppose that for one-to-one, you look at two things that give you the same function value, and then you show that those two things have to be equal. Okay? Then, and maybe I do like I'll do one-to-one on this side and onto on that side. So then we've got 1 over a plus 1 equals 1 over b plus 1. But when you do the cross multiply thing, you get a plus 1 equals b plus 1, and a equals b. Thus, f of x, or just, I'm sorry, f is, sorry again, 1, 2, 1. There we go. If we're going to look at onto, consider y out of that set. Okay? And we've got f of x is equal to this y. Okay? I need to identify what x is and make sure that it's in this range, 0 to that it falls in here. Okay? Then 1 over the quantity x plus 1 equals y means that 1 would be y times x plus 1, yx plus y, 1 minus y equals yx, and then finally that x equals 1 minus y over y, or just 1 over y minus 1. Okay? Since y is in 0 to 1, inclusive 1, when I divide by those numbers, the smallest it could be is 1, and as I get closer to dividing by 0, things shoot off to infinity. And so 1 over y minus 1, well, then that would be in the 0 to infinity range. Thus, f is onto. Okay? That's kind of how you show that. Okay, another famous function from our past, sine of x, defined on all reals to all reals. Certainly we can take the sine of all real numbers, okay, but that's not the question. The question is it one-to-one? And it's not, right? If you remember, again, let me draw the graph of sine function. Here's pi, here's 2 pi, and here's 1, and there's -1. Know that it kind of does this number, right? And then it keeps on doing that. So here's 3 pi and 4 pi. It's just going to do it again. So you think about a horizontal line test, is going to fail that, so it won't be one-to-one. And as far as being onto R, it's only going to go between -1 and 1, right? So it's not one-to-one, since, just give a counterexample, sine of 0 is 0, and sine of 2 pi is 0, but 0 is not equal to 2 pi, right? Two things that gave us the same function value that weren't equal. So it's not one-to-one, and it's not onto, since sine of x equals 2 has no real x as a solution. By the way, it does have a solution. It's just a complex x. It's not a real number. But we're working on the reals, so that's all that matters. Okay? And then C, you might have to stop and think about C. This is from natural numbers to natural numbers, defined by the floor of n squared plus 3 divided by n. And I guess what I had to do is, let's start thinking about, okay, what happens if you start plugging in numbers? And really it made sense to me to simplify this. This is the floor of n plus 3 over n. And the reason that made sense to me is because once n gets up to 4, this is going to be a fractional part, and then this is just a natural number. So once we get to 4, the answer to this is just going to be n, right? But up until that time, it could be something else. So let's see, g of 1 is 1 plus 3. The floor of 1 plus 3 is the floor of 4, which is 4. G of 2, I got 2 plus 1.5, basically 3 halves. So that's 3.5, which is the floor of that is just 3. Oh, by the way, on this top one I was supposed to give the range. If it's not onto, I'm supposed to give the range, and the range for this one is -1-1. I said it, but I forgot to write it down. Okay, I'm sorry. Now back to this one. G of 3, well, I got 3 plus 1 is 4, and the floor of 4 is 4. And then, as I mentioned, once we get to 4 and bigger, this is just less than 1. So whatever this is just going to be n. Okay. Remember, these are natural numbers. Okay. So, is it one-to-one? Well, here's two things that equal the same number, but yet I have different inputs, right? Since g of 1 is 4 and g of 3 is 4, well, 1 is not equal to 3. Is it onto the natural numbers? Well, I don't think there's any way I can get a 1 or a 2, right? So it's not going to be onto. Has no n in the natural numbers. the equation. And so what is the range? Well, it is the natural numbers, but I got to take out 1 and 2. I get 3, 4, and then 5, 6, 7, 8, 9, whatever. But I got to take out 1 and 2. Okay? So that's all we've got with out of 6.1 up until this point. Tuesday we'll jump into them again and start to knock out these problems. I think they'll go pretty quickly. And then once we're done with these things, you know, maybe it runs into Thursday. Our test is next Tuesday, a week from this Tuesday. So, you know, we will review on Thursday for sure, but we may also cover some new material. Okay, we're going to get into the counting of different counting techniques, which I think you'll find are pretty cool and also pretty understandable. I mean, as long as you get them squared away, different kind of things can be a little confusing, but once you get it squared away, then you should be fine. Okay? All right, I'll stop there and see you on Tuesday.